Hello, people on the internet watching videos that have to do with cars. Welcome to this. My 1974 RA21 Toyota Celica, powered by a 2005 Toyota Tundra 2UZ VVTi V8 wrapped in robot spaghetti. If you're new and you like to get caught up on the last part of this wiring series, up above my head is a link to that video, or also could be a cautionary tale of why a belly button is not a built-in pencil sharpener. I got some fresh wires. 100 feet of white 14 gauge as well as 100 feet of black 14 gauge. Where I last left off, I was trying to incorporate the wiring from a 74 Celica into the fuse box of an 85 Celica with the wiring from a 2005 Tundra and making it all factory-ish. I'm gonna do this in the reverse flow of potential. I want this as neat as possible. Do you notice the main ignition wire right here? This is fat white. I think it's 12 gauge, might be 10. That is solid white. So that's why I'm doing solid white on the other positive circuits. The neatest way possible to do this is kind of like a circulatory system with the main artery and all that's disgusting. A better analogy would be like tree roots. So I'll make my branch cuts following the exact same location as the signal wire to each one of the coils, right about there and there. And then it's gonna trace back to its source, flow right up into the fuse box location. I want to triple check my lengths, leave enough room for my strip. I would say it needs to be a hair longer. Now that I got the length of the main root, I want to mark where each one of the main branches, I don't know if roots have branches, I don't know how upside down trees work. I just know in the upside down there's like little white particles everywhere, and Metallica shall be played. The other bundle of wires breaks off predominantly right about here. Now technically this is going to be like another main artery. Gross. If there's an EMT watching right now and I keep saying gross whenever I talk about blood stuff, you probably think this is hilarious. Stay right about there. Again, I'm just going to mark where I'm going to make my branches. There, about there, right about there, on the left side. I used to have a really nice mechanical stripper, not the kind that robots would throw dollar bills at, but the kind that would bite onto the wire and strip just a little bit, but I lost it. So it's really sad and I have to do it this way. Trim that outer jacket. There we go. I just need to rinse and repeat that on every one of my marks. How did one of my hairs end up inside the wire stripper? Just to be safe, I'll make these a couple inches longer than I actually need. The gloves are just a dumb idea for this. Some are gonna argue that soldering is best here, and others will argue that crimp connectors are best. I argue that using one solid continuous strand of wire is best, but that's not possible unless you have a wire octopus. And this is my root of power for the ignition circuit, which shall be laid out. Flop this over. This is like the meat and potatoes of the wiring, the power and the ground circuits. On the factory Toyota 2UZ engine harness, Toyota utilizes an 18 gauge wire for this circuit. And you could argue it's mildly overkill for me to be using a 14 gauge wire, especially when these Denso smart coils only have a few millisecond dwell time. However, there's nothing wrong with erring on the side of caution, and also this will tie into something cosmetically later on. The way in which I'm wiring this, similar to an 85 Celica, you have potential flowing from your battery into the ignition switch. From the ignition switch, when it's in the IG position, it'll send potential to a 7.5 amp ignition fuse. That ignition fuse will then send potential to the coil side of EFI main relay number 2, closing the contacts, allowing potential from the battery to flow through that relay, which will then allow that fused battery power to flow directly to your ignition coil, which there is only one on an 85 Celica. But this circuit is now going to be powering 8 individual smart coil packs. The EFI main relay number 2, as well as the circuit opening relay on an 85 Celica, which that fuse box came from, were located outside of the fuse box. Since EFI main relay 2 was mounted on the fender on an 85 Celica, that means I have to do the same to make this all work similar. Where the fuck did I put my tape? My shop is an absolute mess right now. It's kind of awkward. I can't even walk around the car. That long? That can literally be half the length. Rather than cut the wire and have a bunch of splices, I just bought a ton of extra pins. That way I can just put a new pin on and shorten it. 4 minutes of video you just watched took about 7 hours to film. It's the next day. It was worth it though because I get to check off all of this progress. That was a lot of wiring. The last video I was a bit disappointed by the fact that I realized there was no way to keep a cable throttle on that car without making it a complete hack job. So, shout out to everyone watching this right now that has gone and done the exact same thing I'm doing but didn't know that there was some magnesium in the component you were cleaning, and then you end up ruining it, making it look far worse than it was before you started. Much cleaner. Luckily, that's not the case with this throttle body. How? Aha. Once again, I have changed my mind on the routing of these wires. This is just forever gonna keep happening. And this right here is why I did all my sensors first before doing the powers and grounds. Shorten this up, shorten these up. I must consult my tech data first because the oil control valves also require power, and they're right next to the injectors and the coil packs. Well, that's sad. The truck looked like that at one point in time, except it was black. But oil control valve, where do you get your power? So here are my injectors, the black with the red, that is the power. My coils, black with the red, that is the power. So, oil control valves are right in that vicinity. Does it just get it directly from ECU? I bet you it does. Because it does right here, VVT sensors, O2 sensors. Literally everything is gonna get its power from the ECU, I bet. So basically all those sensors are wired to auxiliary outputs. That is their potential. Which means in a nutshell, aside from 1 or 2 little circuits, everything I got left is grounds. On the Toyota Tundra engine harness, Toyota utilizes a brown wire jacket for the ground circuits. And even though all of the wires for my aftermarket ECU are different colors than the Toyota harness, I can't help but try to replicate the Toyota stuff. This is also being done in a slightly overkill gauge of wire, but again, I'm erring on the side of caution. Welcome to the third day on this video. Keep in mind, these are like 10-hour work days. I don't know where the time is going. I do know where it's going, making robot spaghetti. But this completes pretty much everything on the engine except for the stuff that's under the intake manifold, which is the variable intake runner, the 2 knock sensors, and the starter. And now you see why everyone on YouTube just LS swaps stuff, because electrically you don't have to think. Zip ties. You're supposed to go when you say zip tie. Zip tie. These are gonna get sacrificed. They're just temporary use. And that's how you know I'm nearing completion on the wiring, because I'm going from painter's tape to sacrificial zip ties. Done. For those of you that are not well versed in robot speak, there are 2 things that I learned in tech school for the United States Air Force that drastically helped me understand electrical theory. The first of which is Ohm's law, which is E equals I times R. Now to make that make sense, E represents voltage, the force that triggers flow in the circuit. And yes, these letters don't really correlate to what they actually mean. The E stands for electromotive force. The I, which is for current, amperage, represents the rate. And R stands for resistance, is futile, is ohms, which you see on the multimeter when you're measuring it, is a force inhibitor. This is really hard to explain, especially on a YouTube video where I'm gonna have people screaming in all caps lock that are electrical engineers, or at least think they are, saying, why aren't you talking about coulombs or joules? But yet, you gotta understand, I'm trying to make this digestible by people that don't know anything about electrical theory, so you can at least kinda understand why this is important and how robots dance. And that right there is painstaking progress, but like 90% wired. Because apparently I enjoy torturing myself, I left the abyss for last. Oh man, this is heavy. Why? Oh, this is super heavy. The underside of the intake manifold looks like the underside of a turtle, kind of, in a way, maybe. And underneath it goes this little air bladder for the variable intake runner system, which I don't know if that's gonna clear my hard pipe. Wait, Hard pipe goes on that side. I think we're all right. In the last video, one of you was confused with the fact that I have an aluminum intake manifold and these VVTI 2UZs come with a plastic one. Reason being is this is a 3UZ intake manifold, which I'm using because it looks more period correct, and it's slightly shorter to clear the hood better than the plastic one. The receiver is driven off of the engine's vacuum system, and it's essentially a storage vessel for air to open and close the variable intake runner inside the manifold. It's kind of like a capacitor, but for air. And a dirty one at that. I have to clean it first. You knew that was coming. There. Much better. Hardware. So in addition to this having variable valve timing, it also has the variable intake system and it's drive-by-wire. There's a little bit of complexities to it, but this plug is dicked up. I can fix it though. What's a bummer, this little plug is broken. Geez, those dry rotted. So this right here is a dumb kill waiting to happen. You can see the wires are twisted and coming out of the plug and touching each other. Luckily, I have Sumitomo plugs and connectors and pins for days. Unfortunately, I did not have the pins that I needed, but I have an extra one of these plugs from the other junkyard engine. If you ever wonder how ghouls are made, it's from eating snack food while using lead solder. Okay, it's plugged in. Tighten that. Solving for P is as simple as just knowing your bladder. So we don't need to talk about that one. The other equation that I actually like and find somewhat useful is solving for I. I, which you remember is for current, amperage, is equal to V, voltage, over resistance. So to calculate amperage of a circuit, you can take the voltage, which just use, for instance, this is a 14 volt circuit, and resistance, which is super easy to figure out with a little digital voltmeter. You just isolate it and ohm out that component and you can find the resistance of that item. And say, for instance, a cooling fan, you ohm it out and you get 2 ohms of resistance. Well, you do that math equation, which gives you 7, and that means your amperage draw is going to be 7 amps. And this is the point where people that actually understand electrical theory or engineers are going to scream at me in the comments section saying I left out some critical stuff for calculating things like this. And this is just to get you in a rough ballpark area. Just 7 versus 7.362. Who cares, all right? Just overestimate your circuit. This is a critical component which I must modify, and I don't want to screw it up because this is probably the nicest one I'm ever gonna find. And this is a pipe cutter, usually used for brake lines, fuel lines, smaller stuff, but just gotta put in some work. Which today is also another day. These videos are really not easy to make. Oh, I don't want to mess this up. This stupid little water pipe cost me $150. Speaking of which, this video is sponsored by myself. So if you'd like to support projects like this, down below in the video description is a link to my t-shirts. Okay, there we go. Now this, yeah, just a little guy. So you can see where the heater core lines come out of the firewall right there. And this is welded on right there. I just need a hose that can go like that. Signal goes to 2. Another one is for ground. Sweet, temp sensor. In the valley of the block, I was walking in my sleep to the river of something. No? Okay. Oh jeez. Oh no. This was a dumb idea, put that up there. This is the original harness from my dad's truck. As you can tell, it's covered in moss.
At Green Mountain Furniture, Route 16, Ossipee, New Hampshire.
Which one of these goes to the knock sensor? I cut my finger and I don't have band-aids, so I made a band-aid. Tessa tape comes in handy. So the knock sensors are a shielded circuit, just like the VVTI position sensors and the cam and crank trigger. Hence why it has such a thick outer jacket on it, as well as some tinfoil hat paper and a shielding ground cable. And luckily it uses the same style Sumitomo connector as the injectors, so keeps things simple. This wiring job is so time consuming that the past 2 weeks now, I literally dream about wiring schematics. And I'm not saying that in a funny haha way, I'm saying that as in a clinically psychotic, I need help kind of way. This is getting so bad. I'd be lying if I said I didn't brain dump 90% of the stuff I learned in tech school, and I'm not actually using any of those formulas while working on this stuff, but it is important to have learned those core fundamentals first before trying to tackle stuff like this. Up until this point, I haven't been looming anything just because it hasn't started and ran yet, but for the knock sensors, since they're in the valley, they're gonna get final loomed ahead of time. The Tessa tape not only protects it from heat mildly, it also is flame retardant and it gives it a little bit of chafe protection since it's fabric based. Yep, that's nice right there. That should be nice and protected. The only thing else that goes in the abyss now is the starter because everything else attaches to the back because Toyota engineers thought about that. And that was another plug that I could not get a pin for. So I gotta use one off my dad's harness, which luckily these are all in mint shape since it came from a northern climate. That's it, just one little wire coming from the ignition switch. 8 feet, that should be enough. 10 gauge. I'm replacing wires that matter on this. All the stuff that's in the dash is original, it's 50 years old, but it's in shockingly good condition. So I'm leaving it alone, I've ohmed out a lot of it. That is 50-year-old copper and it's still nice and clean. Ohmed out great too. Stuff that's super important, like ignition switch to starter and starter to battery and all the battery stuff, is getting brand new wire. Push the little lock pin in. Some Tessa tape, protect this wire. That plugs into the side of the starter. And then I just gotta add my big cable to the battery. Don't worry about the mess in my shop, alright? I got more things to worry about than that right now. This for a starter. Now, do I want the wires above or below that pipe? I would say I probably want them above it. That's probably the smartest way to do this. Oh yeah, I almost forgot to show you guys. So the pipe is shortened now. The fellers next door TIG welded it. Came out really good. This pipe goes into the backside of the front crossover. I really hope this pipe clears because this is off of a non-VVTi 2UZ. Clears it, doesn't come in contact. I just realized something is gonna suck. You have to take the intake manifold off to disconnect the starter and the knock sensors. I'm pretty sure it's like that from the factory too. 18 newton meters of torque. One ought to use this wire for a starter. Ooh, and this is welding wire, so it's way more flexible. Oh, this is not really... Yeah, I don't like this one. I was gonna try to start doing the battery circuit, but this is a case in point why you don't buy cheap Amazon brand battery terminal and anything. Don't buy cheap Amazon brand anything. With that said, in the next video, I'm gonna start doing this. I would say that the engine is now fully wired up with the exception of the AC compressor and the alternator, but that's big wire stuff that I'm doing during the battery group, which is, that is another wiring video. I got some parts from Japan for the MR2 that are all here, and it is possible to do a video on this here soon as well. And lastly, I appreciate all of your patience with me through this wiring process. And hopefully I don't dream about wires tonight. I'll see you guys soon with another video. Bye.